we're going to pick up on solving this partial fraction problem. We had just factored the denominator of the original expression using factoring by grouping, and we had set up the initial partial fractions. Since we had x plus 3 on the bottom of the first fraction, that meant 1 power less would be plane A. Since we had x squared on the denominator of the second fraction, 1 power less would be bx, and then you have to keep going down until you get to a constant. Okay, so I'm now actually ready to solve for a, b, and c, and every time I want to do that, I need to multiply by the common denominator. The common denominator you multiply is always the denominator of the original fraction. Do not use anything else. So in this case, I am taking this entire expression times x plus 3 and x squared plus 4. Consequently, when I multiply it times the original fraction, it's of course going to cancel the entire denominator, and I'm going to be left with just the numerator, 10x squared plus 24x plus 8. I will, however, have to multiply it times each of the fractions. So if I take it times the first fraction, I will cancel x plus 3, and that will leave me a times x squared plus 4. If I do the next fraction, I'm going to cancel the x squared plus 4, and I will be left with bx plus c as a quantity times x plus 3. And the other reason to take time to just write out what's remaining so that now I can go back and multiply all this together correctly. So I'm leaving the left side alone here. I'm going to distribute the a, which gives me ax squared plus 4a. And then these other two quantities I will have to FOIL. So bx squared plus 3bx plus cx plus 3c. Okay, now comes the other place where people tend to stall, is what do I do once I get to this point? So now I'm going to go and I'm going to set all my coefficients equal. I'm going to drop off all the x variables. So I notice my highest power of x I see in this problem is x squared. So I could say that I have 10 x squared has to equal all the x squared coefficients, which would be a plus b. Then if I go to the x's, I would have 24 equals, and I would need to find all the x terms, which if I'm looking at here, I'll see that I have 3b plus c. And finally, if I look for the third terms, I'll have 8 equals the constants, which are 4a plus 3c. Okay. As a note, I didn't get to say this morning, if, for example, say there had ended up to be an x cubed over on the right-hand side, and there's no x cubed term on the left-hand side, then you would treat it like you had a 0x cubed out here, and you would set any x cubed terms equal to 0. So if there's something missing, you simply treat it like it's a 0 coefficient. Okay, now you may notice that, okay, great, I've got 3 expressions, and there isn't a single one here which has the same 2 variables in it. I got a and b, b and c, a and c. There's several ways that you can do this. You can do it with substitution or elimination. Since most of you tend to like elimination, I'm going to go that route. What you need to do is put together 2 of these expressions. I'm going to go ahead and put the top 2 together. The variable they have in common is b, so I'm going to eliminate b's. That would mean I'm taking it times negative 3, or the top one. That would give me negative 30 equals negative 3a minus 3b. And then on the second line, I'm not changing it, but notice how I'm lining things up. I'm keeping the variables that are the same lined up. Now, when I actually add down with my elimination, I have negative 6 equals negative 3a, b's cancel, and I have plus c. And you're going, but what good did that do me? I still got two variables and I didn't solve for anything. But now I have an equation with a's and c's, and I have a second equation over here with a's and c's, so I'll be able to do elimination again. Now I'm going to write those together so you can see that. And you would see I have a negative 6 that I just created equals negative 3a plus c. And my last equation over there is 8 equals 4a plus 3c. Now I have two equations with the same two variables, so I will be able to, in this case it looks like c's would be the easiest to eliminate. So I'm going to take the top equation times negative 3 in order to get my c's to eliminate. That will give me positive 18 equals positive 9a minus 3c. I'm going to leave the second equation as is. And so when I add together, the c's cancel, and I have 26 equals 13a, so a must equal 2. Once you've got one variable solved for, it makes the rest much, much easier. You can now go back and you can sub in with your a. Now that you know a, you can find c. So I am going to go with this equation I have right here, the negative 6 equals negative 3a plus c. I could say negative 6 equals negative 3 times 2 plus c. So if negative 6 equals negative 6 plus c, that must mean c equals 0. That's interesting. But it can happen. Maybe one of those variables isn't there. Okay. Lastly then, I need to find b. So I could come back, looks like the very first equation, the 10 equals. I could come back and go 10 equals a, which is 2, plus b, which I don't know, and therefore that means b equals 8. And I've solved for all three variables. Now remember, the final step is to write out the actual fractions. So I have to go back and look at the top and go, okay, a, it was originally a over x plus 3, so my fraction would have been 2 over x plus 3 plus bx plus c would be 8x. c is 0, so it's gone, over x squared plus 4, and there would be my original fractions, my partial fractions that make up the original problem. Now, I know that was great fun, so you all get to enjoy doing that. Have a wonderful time with your partial fraction problems.